to the main root in a spiral sort of fashion. This is weird. And they're really soft. You can tell when you see them in the fossil record, these things are like mush, like spaghetti that's been cooked, not pre-cooked spaghetti, okay? These things they droop. I mean, when you find them in the fossil record, it's clear that they're soft. How do such roots grow through soil? See, the reason they're not called roots is because they can't function as roots. So Joachim Scheven suggested that these were actually aquatic plants, because in the present world we do have this kind of root structure in some plants. They're all very small plants, and all the plants are aquatic. The reason they're hollow is so that they'll float in the water. And the reason they have this strange broom structure to their roots is that's how they're interacting with the water. They pump the water in and out of the plant by using these. So what Joachim Scheven suggested in 1981 was that the coal plants actually were from a floating forest. Now he also argued that it was a freshwater earth and it was only these plants. He wasn't talking about any of the others. My perspective, I was looking at all the Paleozoic plants. He was only looking at basically 3 or 4 species of plants. But he developed this floating forest hypothesis. And so my hypothesis easily took in his anatomical evidence. Now it also takes in another theory that's become rather famous in creationism, and that is Steve Austin's theory for the origin of coal. Steve observed that coal is traditionally explained as being formed in a swamp by debris falling down from above, but you have some things that you see in coal, and that for his PhD dissertation he specifically saw in the Kentucky 12 coal, that are very hard to explain. Coal seams typically have a very flat base. When you take the coal out of a given region, you're usually left with a very flat, you can play football on that field that's left. It's very, very flat. It's also got a flat top. In other words, if you dig in and you take the coal out, all the coal that's there, you're left with something with a very flat ceiling and very flat floor. And very often there are these thin benches or seats in the coal. You call them a bench because if you take the coal off the top of it, you can sit on that bench. I mean, it's a very flat, but the benches might only be a 1/4 inch thick, 1/2 inch thick, 1 inch thick, traceable over counties in distance. But these benches are found in coals as well. And then, microscopically looking at the coal, he recognizes actual anatomical features which indicate we got chunks of bark. In fact, chunks of bark that are upwards of 1 foot in diameter. The problem with the swamp hypothesis is it has a very hard time explaining any one of these things. For example, how do you have a flat base? The trees that are supposedly dropping the debris down have roots that should be working their way into the material below the accumulating area. And so you should have roots that you can follow down into the clay underneath. And it should blur the contact between the peat that's depositing at the bottom of the swamp and the material underneath. You wouldn't expect the flat top. Even worse, flat base. Even worse, how do you flatten the whole thing out? Back when I was in school, I grew up in the Midwest, so I could be deceived into believing a lot of things that occurred in the ocean because I didn't know anything about the ocean. I would ask, well, how do you get this thing shaved off flat? And they'd say, oh, well, a hurricane comes in and shaves it off flat. And, oh, okay. Dumb Illinoisan, I went ahead and bought that. Until I saw the effects of Hurricane Hugo, where there was a beautiful example. There was actually a swamp that was near the ocean before the hurricane, and the hurricane came in and blew that swamp away, literally. And ironically enough, there was a town inland, so it took most of the debris from that and dumped it on the town. But I mean, there wasn't a green thing left in that swamp. But the last thing you'd ever accuse that swamp of being at that point is flat, because you couldn't walk across it. There would be huge trees that are broken off at about 10, 12 feet above the ground or ripped out by their roots, and their roots are sticking way up like this. And there's the smaller trees, of course, would be broken off a little bit lower, and then there's things broken and crossed all over. It wasn't flat. They couldn't flatten it off with the bulldozers. So how in the world do you get it flat? And it doesn't stop there. Because what about those crazy benches right in the middle of the coal? Because in order to get that bench, you first have to flatten off the stuff that's already there. Okay, let's assume you can do that. Now let's put a half an inch of mud over a county. Now let's grow a swamp on top of it again without disturbing the mud. Don't touch the mud. That doesn't work. You can't do that. Okay? And I'm going to make it worse by saying there are marine fossils in the mud. And then the chunks of bark and the coal. I mean, if you go to these peat bogs and you drain them off and you look at the debris, you can't recognize any plant parts. It's got, as Steve used to call it, the consistency of coffee grounds. It's the roots and the decomposition break those pieces up. You don't find chunks of bark in there. What you do find are roots of the living trees, but that you don't ever find in the coal. So how in the world do you have these chunks of bark, flat base, thin benches, flat top? Well, of course, Steve looked at that Kentucky 12 coal and thought, well, this is not going to work. And so according to him, when he was in a bathtub playing with bubbles, he came up with an idea that maybe what's going on is, given the fact that these are hollow trees with bark, we have log mats of these hollow trees. And as they're floating around on top of the water, they rub up against one another, break off the bark. The bark then waterlogs down to the bottom. You can have a flat surface at the bottom of this body of water. The bark begins to accumulate. The log mat gets blown somewhere else. Mud can come on top. A half an inch of mud can come in. The log mat can come floating right back over again and start the deposition of coal again, and then float away. And you've got flat bottom, flat top, the benches. You can explain the pieces of bark in there. It's an elegant hypothesis. And in fact, he successfully defended his PhD dissertation in 1979. Interestingly enough, in 1980, of course, Mount St. Helens blew up and created a laboratory example of his hypothesis. Less than a year later, 1 million logs floating on the top